Hey, hello, and welcome to today's session on time series databases. So, have you ever wondered how your smartwatch records your heartbeats per second every second? Or the stock exchanges, how they record the stock prices of thousands of stocks every second? Or how does Netflix monitors their thousands of servers every second? Okay, all this data is powered by something called time series databases. Okay, so first of all, let's see what is time series data. Okay, so data points which are recorded over time. Okay, or data points or the records which has timestamp associated with them. Okay, so let's see an example. So here is an example. Okay, so here is an example of the monitoring of the servers basically. So if you see, so we have CPU usage as a data points, right? So here is a CPU usage of server one. Okay, and it has timestamp associated with it. That is at 10 hours and 5 seconds the CPU usage was 30%. At 25 seconds it was 45%, and at 45th second it was 60%. So the data points are associated with the timestamp, if you see, right? So each data point is associated with the timestamp. Okay. And this data, they come in huge volume. As I said, within every second, we get the data point basically. So within every second, we get what is the CPU usage of the various servers. So this is an example of server one. So in short, the data points or records associated with timestamp, every data point or record associated with the timestamp is called time series data. Okay. So now let's see what is a time series database. Okay, a time series database is optimized for timestamp data. We have already seen what is timestamp data. Okay, these databases handles millions of inserts per second. That is, they are, I mean, their writes are very fast. The writes in these databases are very fast. Okay, and they are built for time range queries. We'll see an example what are time range queries. I mean, the queries, each query having timestamp, okay, from this time to that time. Okay, for such queries, time series database is the suitable database. Is they are built for time range. These databases are built for time range queries. Okay, so they have built-in retention and downsampling. Okay, so first of all, let's see how they're optimized for timestamp data. So I'll give you an example. I'll give you an example of InfluxDB, which is a time series database. Okay, so here, if you see, here is the input data. Okay, here is input data. This data is coming every second. Okay, so what happens is this data is ingested, is submitted to the InfluxDB cluster. Okay, and what the InfluxDB cluster or what the InfluxDB node does is it writes whichever data comes, right? The data point comes one by one, and it keeps on appending into a file called write ahead log. Okay, write ahead log. So it just appends into write ahead log file which is on disk. Okay, and it also ingests the data point into the memory. Okay, so it does two things. It just appends the data point which we just saw, right? The CPU usage every second the CPU usage, it appends, it just makes an entry in the write ahead log file. And another thing is, in another step, it just inserts into the memory. And this is the reason why the writes are very fast in these databases, because they are ingesting the data in memory, and they write the data in the write ahead log file. They just append the data which is on disk locally. They just append the data, which is why the writes are very fast. They don't have to like go ahead, right? For example, there's a data point coming in and they want to sort, or they want to find the right place in the write ahead log file. No, it is just an append only file, and this is the reason. And second is, it just writes into the memory, and writing in the memory, it's cheap. It's very cheaper than writing on disk. Okay, so these are the two reasons why the writes are fast. Okay, now why we are writing in the write ahead log file? In case the memory crashes. Okay, so we need to have the data point persisted somewhere, right? And that is why we are writing in the write ahead log file which is stored on the disk. Okay, so for example, now once this memory gets full, once this memory gets filled, so what it does is it flushes the data onto files called time structure merged files. Okay, wherein here the data is indexed based on the timestamp, so if you see here, right, so here it is this CPU usage, which is nothing but, you can say, it's a measurement which in SQL databases we call tables, right? Here in InfluxDB we called measurement. So CPU usage is a table you can consider, and these are the tags basically. Server 1, so which server, right? Server 1, and which is the region, which is US East. And if you see, these data points are sorted based on the time, based on the timestamp. Okay, and here's the actual data point, the usage, the CPU usage. Okay, so storing the data in this way, sorted according to timestamp or indexed according to timestamp, makes it very suitable for queries using the timestamps. So now we'll see the sample queries. Okay, so we saw how the database is optimized for timestamp data. We saw, right, the data is indexed or it is sorted according to the timestamp, which makes it very easy to query based on the timestamps. Okay, so what are the sample queries? So as I said, right, as I said, one of the features of time series database is fast time range queries. So if you see here, right, so just this is a sample query again, wherein we are selecting the usage, which is the CPU usage from this particular table, and the timestamp. So here is a timestamp in the query itself, right? From what we are saying, from where time is greater than this, within this time range basically. And this is another sample query wherein we are doing the aggregation basically of the usage from this time, from this time. Okay, from the in the last 1 hour, okay, what is the average usage, mean usage, what is average? So this is nothing but aggregation, and these both the queries, they are based on the timestamps, if you see. So this is what timestamp databases are based on. Like, one of the features when to use timestamp databases, when your data point, when each record or your data point has a timestamp associated with it, and each of your query has timestamp basically. In the where condition, there are timestamps. Okay, then it is suitable for time series databases. Okay, and I have also explained why the writes are fast, why the time series databases can handle millions of inserts per second, because it writes the data into the memory, which is very fast. You know, when we write data into the memory, it's very fast, and it just appends into the write ahead log file. It does not go and find the right place. Okay, what is the offset and all? It just appends. Okay, so that is why the writes are very fast in timestamp databases. Okay, another feature of timestamp databases is built-in retention and downsampling. I mean, you can provide the retention policy that, okay, my data will is going to stay for 7 days or 1 month or a year. Okay, so you just have to set the policy, okay, the retention policy, and downsampling. So what is downsampling? So one of the out-of-box features which timestamp databases provide is downsampling. So let's see an example. What is downsampling? Okay, so here you can see, right, within each minute, like at 10 hours and 5 seconds, 25 seconds, and 45 seconds, this is the CPU usage. And within 10 hours, 1 minute, okay, 1 minute and 5 seconds, 25 seconds, 45. So this is the CPU usage. Now I want to downsample per minute. So if you see here, within a minute, at 10 hours, the average CPU was 45%. I mean, what it did was this plus this plus this divided by 3. Okay, within a minute, it is aggregating, or it is calculating, or it is downsampling the CPU usage. Okay, it is taking the mean. Okay, within that minute. Second example is, if you see, right, at 10 hours and 1 minute. Okay, at 10 hours and 1 minute, it is aggregating or taking the mean of these timestamps. So what we call, so at 10 hours it is 45%, and at 10 hours 1 minute it is 56.7%. Okay, so this is what we call downsampling, and this is one of the out of box features which the time series databases provide. Okay, so I hope you have got the features of time series database. Okay, now let's go ahead and see why not SQL databases. I mean, why we cannot store such data into SQL databases. Okay, SQL databases can store time series, but they struggle with high writes data. Okay, so we have seen, right, why the writes are very fast in time series databases. In SQL databases, the writes are not as fast as compared to time series databases or LSM based databases. Why? Because the SQL databases, they generally store the data in B plus trees. Okay, in B plus trees. But we have seen why the writes are fast in the time series databases, because they write in memory and they append the data point into they just make an entry basically into the write ahead log file. Okay, but SQL databases, they are not as optimized for writes as the time series databases. Okay, and second is billions of rows. As I said, right, we get the time series data is the flow of continuous data. Okay, with every second, within every second, we get continuous flow of data. So there are huge data volume, and like the problem of scalability in SQL database, right? In SQL databases. Third is retention policies. Now they don't provide out of the box. SQL databases don't provide out of the box retention policies. You need to write your own retention. Basically, you need to write your own code. Okay. Then another one is downsampling. It does not provide out of the box downsampling feature like time series databases. We have just seen example of downsampling, right? It aggregates basically the data. Okay. So that is why SQL databases are not suitable for such time series data. Okay. Now, what are some real world use cases? Real world use cases are monitoring and observability. We have seen like CPU usages, right? Monitoring the servers, basically the memory usage, the disk usage and all. Okay, or the IoT or sensor data, basically like we see in the smartwatch data and all, right? Smartwatch or temperature in the living room when the continuous temperature data is being sent or recorded, or the finance as we have seen, right? Uh, the stock prices, within each second the stock prices are recorded, right? And another one is trends. Basically the trends can be in any product, right? The trends like within last 7 days or within a month, such trends, right? Wherever it is. So these are some of the real world use cases when timestamp databases are suitable. Okay. Now, what are the some of the popular time series databases? One of the time series databases, InfluxDB, okay, which is suitable for IoT, generally suitable for IoT and metrics. Okay, IoT, as I've already given example, like smartwatches or your temperature recording device. Then Prometheus, we have the monitoring and Kubernetes monitoring of the servers, right? The CPU usages and all. Then we have other databases like TimescaleDB or QuestDB or VictoriaMetrics, which is for cloud scale monitoring, or KDB for finance and trading systems like stocks and as I've already mentioned, right? Now, sir, there are some other non-time series databases like ClickHouse or Amazon Redshift or even Cassandra. Okay, they also can be. These are some of the columnar like cloud. This ClickHouse or Amazon Redshift. These are columnar databases. These like time series data can also be stored in these databases. Okay, but they are used. The time series data can be used for analytics, but not for real time monitoring with these databases like ClickHouse or Amazon Redshift. Okay, you can ingest the time series data. They are suitable for time series data, but only for analytics purpose. For the past data, I mean, whatever you want to do analytics, right? The aggregations and all, you can do that. But real time monitoring, no, they are not suitable for that. Okay, so these are some of the popular time series databases. Now comes an important um, algorithm which the time series databases use for the storage optimization. So we'll see an example. Okay, so one of the features of time series, one of the very good feature I'll say of time series database is compaction or compression. Okay, so let's consider this example. Now for example, we saw that let's consider what do we say, the smartwatch data. It records your heartbeats, right? So what is an average? I believe it is 60 to 100, I believe, the average heartbeat, right? So what is the variance if your heartbeats is per second? If it is recorded, what will be the variance? It is going to be like this, right? 60, then 62, right? Then 62, or maybe 58. Okay, again 60, now 65. Okay, so if you see, so these data points have very low variance among them, very low variance. Or let's consider the CPU usage. Okay, at very few times there is anomaly. For example, the CPU usage, right? Now it is 30%. Then yeah, it has fluctuations, but the variance within each fluctuation is very low, 32%, 30%, 28%, right? So generally the variance for the time as they're recorded within the time window is very small, within second. So the variance between the data is very slow. I mean, very less. I mean, the frequency is very less when there's a big anomaly. Okay, that is from 30 to it reached to 80% or something. So it happens rarely, basically. Okay, so what happens is, so as the time series data has very low variance, okay, so it makes it very suitable for compression or compaction. So we'll take an example, just some metric. Okay, some metric. Okay, and as I said, the variance within each between each data point, it's very low. Okay, so this makes it very suitable for compression, and we'll see how. Okay, so how time series database does is it first records the first data point is first records as is. Okay, 10,000 is stored as is, but from the next one, okay, we store only the time series database store only the delta between the two consecutive numbers. So delta. So for example, between 10,005 and 10,000, what is the delta? It is 5. So 5 is stored. Within 10,005 and 10,007, what is the delta? 2. So it is stored like this, 2. So this, because of the variance, because of the low variance, so it is compressed in this way. Okay, it is compressed in this way, and hence it makes it very storage optimized. Okay, it makes it very storage optimized. So if you see delta of 2, okay, so first number is stored as it is. Okay, now, but what if first of all, what is a naive way of storing this data? Okay, of storing this data point. So it can be stored in 8-byte integers, right? It can be stored in 8-byte integers. Okay, this is a naive way. Okay, but with the delta compression, as we saw, right? We are just storing the delta. Now we can definitely reduce, right? We can definitely use less storage to store these small numbers, right? But if we store these numbers in the 8 bytes, will we get any optimization? No, because you're storing, if the numbers are small, you're still storing in the 8-byte integers. Okay, so what we can do here is we can store this data in something called var-ins. Okay, variable ins. Okay, so for example, this 10,000, it is taking, for example, it can take 8-byte integer, but for storing 5 or 2, it can take only 2 bytes to store the data. It need not require 8-byte. Okay, it need not require 8-byte. So we'll see an example. Okay, so storing the data in var-ins. Okay, I mean storing whatever is the requirement of the data, right? So as I said, 5 and 2 can be stored in 2 bytes. So this is where the optimization is happening. Okay, what is a naive way to store, even if the number is small, just store in 8-byte integer? Okay, but here with delta compression and with var-ins, you can optimize, the storage is optimized uh, in a very good way. Okay, so we'll see an example. Let's take an example of 292. This is a decimal. Now what is the binary representation of 292? It is 100 100 100. Now storing in variant. Okay, let's see how it gets stored. So this is 1 byte, right? This is 1 byte, and this is 1 byte. Okay, there are 8 bits. So these 6 bits are stored here. Okay, these 6 bits are stored here. Okay, and this one, it denotes that there are more bits. Basically, there are continuation bits as well, present as well. Okay, so what are the remaining what are the remaining bits? So these are the two remaining bits. Okay, these are the two remaining bits. Okay, so these two remaining bits are stored here, 10, and rest, the remaining bits, I mean, zero is stored basically. So if you see, this 292 can be stored in 2-byte integer, in 2-byte variant. We can encode this 292 in 2-byte variant. Okay, so you have just seen the last 6 bits are stored in 1 byte. Okay, then this number 1 denotes that there are subsequent bits as well. There are subsequent bits as well, which is stored in another byte. We just saw it is stored in another byte, right? So this is how time series database is optimized for storage. Okay, it does delta compression. Okay, because of the low variance, like there is a huge scope for compression, and this is how your storage is optimized. This is how, yeah, it's optimized. Okay, so this is it. I hope you have got the gist. Time series database, and what is time series data, and how and in which use cases we can use time series databases. Okay, thanks for watching. I hope you have got this session. Okay, please like, subscribe, and follow me on LinkedIn. Thank you so much.